In July 2025, a telescope in Chile caught a faint speck of light racing through the sky at over 200,000 kilometers per hour. Nothing in our solar system moves like that naturally. Within hours, astronomers around the world understood they were looking at something that didn't belong here, an object that had been drifting through the emptiness between the stars for possibly billions of years, long before our sun even existed. This was only the third time in human history that we had ever confirmed such a visitor. Scientists named it 3I Atlas. And almost immediately, the internet exploded with the same question that had gripped the world back in 2017, when the first ever interstellar object, ʻOumuamua, tumbled past Earth. Is this thing natural, or is it something else? In this video, we're going to break down exactly what 3I Atlas is, how it compares to ʻOumuamua, what NASA, ESA, Harvard, and independent observatories have actually discovered about it, and why some scientists still can't stop arguing about it. Stick around, because the real data is honestly stranger than the rumors. Before we get into 3I Atlas itself, let's set the stage, because this context matters. Every comet and asteroid we've ever tracked before 2017 belong to our solar system. They orbit the sun in closed loops, ellipses, some taking a few years to go around, some taking thousands. But every single one of them is gravitationally bound to the sun. They came from here, they stay here. An interstellar object is completely different. It isn't orbiting the sun at all. It's just passing through on a one-way trip. Astronomers can tell the difference by looking at the shape of the object's path, called its orbital eccentricity. A closed orbit has an eccentricity less than 1. A parabolic path is exactly 1. Anything with an eccentricity greater than 1 is called hyperbolic, meaning the object is moving too fast for the sun's gravity to ever pull it back. It came from outside. It will swing past the sun once, and then it will leave forever, never to return. For most of astronomical history, we assumed such objects existed in theory, but had never actually caught one in the act. That changed in October 2017, when the Pan-STARRS telescope in Hawaii spotted a small, fast-moving object later named ʻOumuamua, a Hawaiian word roughly meaning scout or messenger from afar. It was the first confirmed interstellar object ever recorded, and it kicked off a wave of fascination, speculation, and scientific debate that hasn't really stopped since. 2 years later, in 2019, an amateur astronomer named Borisov discovered the second one, a much more ordinary-looking comet that was named 2I Borisov. It behaved almost exactly like a typical solar system comet, with a visible tail and a fairly standard chemical composition, which reassured a lot of scientists that these interstellar visitors weren't going to be constant mysteries. Then, on July 1st, 2025, the Atlas Survey Telescope, short for Asteroid Terrestrial Impact Last Alert System, located in Rio Hurtado, Chile, picked up a new object roughly 675 million kilometers from the Sun. Within a day, the Minor Planet Center had confirmed it as the third interstellar object ever discovered. It received the formal designation 3I Atlas, with 3I meaning it's officially the third interstellar object cataloged, and it was also given a normal comet name, C2025N1. By the time it was officially announced, more than 100 observations from over 30 different observatories around the planet had already confirmed its hyperbolic, unmistakably interstellar path. So, right from the start, we already know 3I Atlas wasn't some fringe discovery. It was confirmed fast, tracked by dozens of professional telescopes, and treated as a top priority target by nearly every major space agency on Earth. Here's where things get genuinely wild, and this is all backed by real observational data, not speculation. When 3I Atlas was first discovered, it was already moving at roughly 137,000 miles per hour, or about 221,000 kilometers per hour. As the sun's gravity pulled on it during its approach, that speed increased further, reaching around 153,000 miles per hour, close to 246,000 kilometers per hour at its closest point to the sun. And here's the part that really matters. Once it swings back out of the solar system, it will leave at essentially the same blistering speed it came in with. The sun's gravity can bend its path, but it can never capture it. To put that in perspective, this is the fastest object relative to the sun that has ever been recorded passing through our solar system. Faster than ʻOumuamua, faster than Borisov, faster, frankly, than almost anything we've ever tracked. Why does speed matter so much? Because velocity is basically a fingerprint of age and origin. Objects that have been drifting through interstellar space for a long time pick up extra momentum over billions of years through countless gentle gravitational nudges from passing stars and nebulae, kind of like a pinball bouncing gently off bumpers for an eternity before finally rolling into our table. The faster an object moves, generally, the older and more traveled it likely is. This single clue is part of why astronomers now believe 3I Atlas might be extraordinarily old, potentially older than our own sun, which is about 6 billion years old. Now let's talk trajectory. Astronomers traced 3I Atlas's tilted path and found that its orbit carries it much farther above and below the plane of our solar system than anything native to our neighborhood would. When you extend that path backward in time, it clearly originates from far outside the solar system altogether. It simply never came from anywhere near the Sun's family of planets. It's also worth noting that the comet did not pass close enough to any planet to have picked up its extreme speed through a gravitational slingshot inside our solar system. That rules out the idea that it's some kind of native object that got flung out and is now just passing by again. Its speed had to have come from somewhere else, somewhere out among the stars. At its closest approach to the Sun, which happened around October 30th, 2025, 3I Atlas came to about 4 astronomical units, roughly 210 million kilometers just inside the orbit of Mars. And in terms of danger to Earth, none, 0. The closest it ever got to our planet was about 8 astronomical units, or roughly 270 million kilometers away, nowhere close enough to pose any threat whatsoever. If your algorithm has shown you thumbnails screaming, "It's headed for Earth," you can safely ignore them. It was never on a collision course, and NASA confirmed this early and repeatedly. Size estimates for interstellar objects are notoriously tricky, mostly because these comets are usually shrouded in a hazy cloud of dust and gas called a coma, which makes it almost impossible to directly see the solid nucleus underneath. NASA's Hubble Space Telescope captured its first images of 3I Atlas on July 21st, 2025, when the comet was about 446 million kilometers from Earth. Those images revealed a glowing, teardrop-shaped cocoon of dust surrounding the nucleus, along with a faint tail beginning to stream away from it. Based on that data, astronomers led by UCLA's David Jewett calculated that the solid nucleus could be no larger than about 6 kilometers across, though it could be as small as roughly 320 to 440 meters in diameter. That's a wide range, admittedly, but it's a real constraint based on actual light reflection measurements, not guesswork. Interestingly, later analysis using the comet's non-gravitational acceleration, essentially how much the outgassing jets nudged its trajectory, suggested the nucleus might actually be on the smaller end, somewhere close to a single kilometer across. Scientists continue to refine this estimate as more data comes in, which is completely normal for a new interstellar visitor we've only been watching for less than a year. For comparison, ʻOumuamua was estimated to be much smaller and unusually elongated. Some models suggested a cigar-like or pancake-like shape roughly 10 times longer than it was wide, though even that shape estimate has been debated and revised over the years since 2017. The key difference is that ʻOumuamua showed no visible coma or tail at all when discovered, which is part of what made it so strange in the first place. 3I Atlas, by contrast, is unmistakably active. It's behaving like a genuine comet, complete with dust plumes, gas emissions, and a visible tail, all documented across multiple observatories. This is the part of the story that has kept astrochemists up at night in a good way. The James Webb Space Telescope turned its near-infrared spectrograph toward 3I Atlas starting in August 2025, and what it found was unusual. The comet's coma showed an extremely high ratio of carbon dioxide to water, far higher than what we typically see in comets native to our own solar system. A team led by NASA researcher Martin Cordner proposed 2 possible explanations. Either the comet's nucleus is unusually rich in carbon dioxide ice, possibly because it formed very close to the carbon dioxide frost line in its home star's planet-forming disk, or it has an unusually thick insulating crust that's holding back water vapor from escaping as easily as the carbon dioxide. Then, in 2026, newer observations added another twist. Cordner's team detected a methane-to-water ratio roughly 11 times higher than anything ever measured in a solar system object. That's an enormous anomaly, and it made headlines everywhere. But here's the important part that a lot of viral clips leave out. Scientists have explained this as a natural outcome of thermal outgassing processes, not evidence of anything biological or artificial. Different ices sublimate, meaning turn from solid to gas at different temperatures, and as 3I Atlas warmed up on its way toward the Sun, its more volatile ices likely vaporized at different rates than water does, skewing these ratios in ways we don't often see simply because we've never had this close a look at a comet formed in a completely different star system before. Meanwhile, other instruments told a slightly different story. Observations of the coma found a carbon monoxide to water ratio of about 4, which is actually very similar to ratios seen in typical solar system comets, and also similar to what was measured in 2I Borisov, the second interstellar object. So in some ways, 3I Atlas looks like a fairly normal comet, and in other ways, it looks like nothing we've ever measured before. That contradiction is exactly why scientists are so excited. It's giving us a real physical sample of chemistry from outside our own solar system, something we've almost never had direct access to. Then came arguably the most remarkable single discovery of the entire story. In early 2026, a team led by University of Michigan PhD student Luis Salazar Manzano, working with astronomer Teresa Paneque Carreño, used the Atacama Large Millimeter Submillimeter Array, ALMA, in Chile to measure something called deuterated water, sometimes nicknamed heavy water in the comet's coma. Deuterium is a heavier form of hydrogen, and the ratio of heavy water to ordinary water in a comet acts like a chemical thermometer, telling scientists how cold the environment was when that ice originally formed. What they found was staggering. 3I Atlas contains at least 30 times more heavy water than typical solar system comets, and more than 40 times the proportion found in Earth's oceans. This was the first time scientists had ever successfully measured this specific ratio in an object that formed around a completely different star. The implication is that 3I Atlas likely formed in an extraordinarily cold environment, colder even than the outer fringes of our own solar system, hinting that its home star system may have been very different from ours. On top of that, separate observations using the European Southern Observatory's Very Large Telescope in Chile measured the ratios of carbon and nitrogen isotopes within cyanide molecules in the comet's gas. These isotope ratios function almost like a fingerprint of a comet's formation environment, and astronomer Cyrielle Aupetom and her team concluded that 3I Atlas likely originated in the outer regions of an old star system, possibly one considerably older than our own sun. If that holds up, 3I Atlas could be a genuine fossil, a frozen leftover from a planetary system that existed long before Earth ever formed. Okay, let's address this directly, because it's the reason a lot of you clicked on this video in the first place. Shortly after 3I Atlas was discovered, Harvard astrophysicist Avi Loeb, who also famously proposed years earlier that ʻOumuamua might have been an artificial probe or even a piece of alien technology, suggested that 3I Atlas's unusual trajectory and properties were worth investigating as a potential technosignature, meaning a possible sign of extraterrestrial engineering. Loeb has continued to raise questions publicly, including pointing to the unusually high methane levels and asking, in interviews, whether such chemistry might hint at some kind of biological or artificial process rather than a purely natural one. To be fair to Loeb, he has also stated plainly in his own writing that the most likely outcome is that 3I Atlas is a completely natural interstellar object, most probably a comet, and that he views the alien probe hypothesis as an interesting intellectual exercise worth exploring rather than a firm claim. Still, his public comments reignited the same kind of media firestorm that surrounded ʻOumuamua back in 2017 and 2018. Other scientists have pushed back fairly hard. Astronomer Samantha Lawler noted that while it's healthy to stay open-minded about testable predictions, some of the reasoning in these alien probe papers stretches that open-mindedness to its limit, arguing that extraordinary claims require extraordinary evidence, and that the evidence presented so far simply isn't extraordinary enough to support such a dramatic conclusion. But here's the good news for anyone who actually wants a real answer instead of just speculation. Scientists didn't just argue about this online, they tested it directly. The SETI Institute, using the Allen Telescope Array at the Hatch Creek Radio Observatory in Northern California, began scanning 3I Atlas for radio technosignatures within 24 hours of its discovery being announced. Over more than 7 hours of observation across a frequency range of 1 to 9 gigahertz, the team detected nearly 74 million individual radio signals. After filtering out human interference and satellite signals and narrowing down to signals that actually matched the comet's motion across the sky, only about 200 candidate signals remained for closer review. None of them showed any signs of being artificial transmissions. Every single one traced back to Earth-based technology or satellites. Separately, the Breakthrough Listen program, widely considered the largest scientific initiative in history dedicated to searching for signs of intelligent civilizations, conducted its own technosignature search using the Robert C. Byrd Greenbank Telescope in West Virginia as the comet made its closest approach to Earth in December 2025. Out of roughly 470,000 potentially interesting signals, researchers narrowed it down to 9 candidates that appeared only when the telescope was pointed at the comet. But every one of those 9 was later ruled out as ordinary human-made radio interference. A study connected to this research, led by scientist Sophia Sheikh, concluded plainly that there is currently no evidence suggesting interstellar objects are anything other than natural astrophysical bodies, while also acknowledging that because we've only found 3 of them so far, continuing to check each new one thoroughly is simply good scientific practice. So, to answer the big question directly, as of the most recent data available, multiple independent teams, using different telescopes and different methods, have searched 3I Atlas for any sign of artificial technology, and all of them came back empty. The overwhelming scientific consensus from NASA, ESA, SETI, and the broader astronomical community is that 3I Atlas is a natural comet, a genuinely fascinating, chemically unusual, remarkably ancient comet, but a comet nonetheless. Now, let's bring this back to the question in our title. Is 3I Atlas really the next ʻOumuamua? The honest answer is yes and no. Yes, in the sense that both objects are confirmed interstellar visitors, both triggered massive public fascination, and both prompted serious scientific debate about their origins. Yes, in the sense that both objects have unusual properties that don't perfectly match typical solar system comets or asteroids. But no, in almost every specific detail, these two objects are strikingly different. ʻOumuamua showed no visible coma, no detectable gas emissions, and no obvious cometary tail when it was discovered, which was deeply strange, because comets normally reveal themselves through exactly those features as they warm up near the sun. This absence of typical cometary activity, combined with reports of a subtle, unexplained acceleration as it left the solar system that couldn't be fully explained by gravity alone, is exactly what first led Avi Loeb and a small number of other scientists to propose, back in 2017 and 2018, that ʻOumuamua might have been artificial, possibly a light sail or some kind of technological fragment. Most astronomers at the time and since have instead proposed natural explanations, such as the idea that ʻOumuamua was made of unusually pure hydrogen ice, or that it experienced a kind of outgassing too faint for our instruments to directly detect. 3I Atlas is the opposite story in almost every way. From very early in its discovery, telescopes detected clear signs of a coma, a genuine dust tail, and active gas emissions, including carbon dioxide, carbon monoxide, water, and methane. It behaves observationally far more like a traditional comet than ʻOumuamua ever did. In that specific sense, 3I Atlas actually has more in common with the second interstellar object, 2I Borisov, which was also clearly an active, gas-emitting comet. Where 3I Atlas truly stands apart from both of its predecessors is in its extremes. It's the fastest interstellar object ever recorded. It appears to be significantly older than the Sun itself, based on isotope and chemical analysis. And thanks to its brightness and how early it was detected, nearly 2 months before it reached its closest point to the Sun, it has now been observed in more scientific detail than either ʻOumuamua or Borisov ever were. ʻOumuamua was discovered only after it had already passed its closest approach to the Sun and was on its way out, giving scientists just a few frantic weeks to study it before it faded from view entirely. 3I Atlas, by contrast, has been tracked continuously by an enormous array of instruments: Hubble, James Webb, the Very Large Telescope, ALMA, SphereX, TESS, and even spacecraft as far-flung as NASA's Mars orbiters, the Europa Clipper, the Psyche mission, and Europe's JUICE spacecraft heading to Jupiter's icy moons, several of which happened to be well-positioned to catch glimpses of the comet as it passed through the inner solar system. In fact, in a genuinely remarkable stroke of luck, NASA's Europa Clipper spacecraft was predicted to pass directly through the comet's ion tail in late October and early November 2025, giving scientists a completely unprecedented, up-close opportunity to sample material from an interstellar object using instruments not originally designed for that purpose at all. So if ʻOumuamua was a fleeting, mysterious flash we barely got to study, 3I Atlas has been the polar opposite, a slow-motion, richly detailed scientific bonanza, observed by nearly every major telescope and spacecraft humanity currently has access to. 3I Atlas made its closest approach to Jupiter around mid-March 2026, and NASA's Juno spacecraft, which orbits Jupiter, was considered as a possible additional observer, though the spacecraft's limited remaining fuel and known engine issues make it unlikely that it will be specifically redirected for this purpose. As the comet continues its journey away from the Sun, it will keep getting fainter and fainter. It reached what astronomers call opposition, meaning it was visible in the sky all night long, around January 22, 2026, though by that point it was already fairly dim. Ground-based telescopes like the European Southern Observatory's Very Large Telescope will continue observing it for as long as possible. But eventually, like all interstellar visitors before it, 3I Atlas will simply become too faint and too distant to track. It is now on its way out of our solar system permanently, and it will never return. And once it leaves, there's no bringing it back for a second look. Everything scientists are going to learn about this object. They need to learn now, while the data is still coming in. Looking further ahead, the newly commissioned Vera C. Rubin Observatory in Chile, along with Europe's upcoming extremely large telescope, are both expected to dramatically increase how many interstellar objects we detect in the coming years. Astronomers widely expect that instead of finding just one interstellar visitor every few years, upcoming survey telescopes could start spotting several per year, which means 3I Atlas likely won't stay a rare curiosity for very long. It may end up remembered as the moment we transitioned from occasionally stumbling across interstellar visitors to routinely studying them. Here's why any of this actually matters beyond the headlines and the alien speculation. Every planet, moon, comet, and asteroid we've ever studied up close came from our own solar system, meaning it formed from the same original cloud of gas and dust that created our sun about 6 billion years ago. Interstellar objects like 3I Atlas are different. They are physical samples, real, touchable material, even if only touchable by spacecraft flying through their tails, from a planetary system that formed somewhere else entirely, around a completely different star, potentially billions of years before our own solar system even existed. That makes objects like this genuinely priceless from a scientific standpoint. It's the closest thing we currently have to sending a probe to another star system and bringing a sample home, except in this case, the sample came to us. Every measurement of its water, its carbon dioxide, its isotopes, and its dust grains is a tiny window into the chemistry and physics of an alien planetary system, something astronomers have only ever been able to guess about indirectly through telescopes pointed at distant stars. So while the "Is it aliens" headlines will keep grabbing clicks, the real story of 3I Atlas may end up being even more profound. It's direct, physical evidence about how planets form throughout our galaxy, evidence we've almost never had access to before, delivered to our own cosmic backyard, completely by chance. So, is 3I Atlas the next ʻOumuamua? In terms of the mystery and the excitement it's generated, absolutely. In terms of what it actually is, the evidence overwhelmingly points to something both simpler and more incredible than an alien spacecraft. An ancient, active, chemically unique comet that may predate our own sun, caught passing through our solar system purely by cosmic coincidence, and studied in more scientific detail than any interstellar visitor before it. If you found this breakdown useful, let me know in the comments which discovery surprised you the most. The heavy water, the methane levels, or the SETI search results. And if you want more deep dives into real, verified space science without the clickbait, make sure you're subscribed, because interstellar objects like this one are about to become a lot less rare. Thanks for watching, and I'll see you in the next one.